Hi, my name is Mark Lobanoff, and I'm here today to present Phorcides Analytic Engine software to you, teach you a little bit about how it was developed, why it was developed, and a little bit how to use the software in your day-to-day planning of cases. So why was Phorcides designed in the first place? And we have to go back to the beginning for when Alcon first rolled out Contura into the United States. And this came fresh off the FDA trial where Alcon had approval for topographic guided LASIK, and the FDA trial results were amazing. In the FDA trial, over 88% of patients were achieving 20/20 visual acuity at 1 month, and 59% were achieving 20/15 uncorrected visual acuity. However, when Alcon rolled out Contura into the US market, it quickly became evident that surgeons were not getting the same results as had been seen in the FDA study. And here in orange are my results from North Suburban Eye Specialists, and the published results from John Canelopoulos are shown in yellow. And what you can see is neither John nor myself were able to achieve the same levels of 20/20 uncorrected as the FDA study in green. And definitely at the 20/15 level, we really fell short. So roughly approximately 1 in 3 of our patients were achieving that 20/15 uncorrected visual acuity that had been seen in the FDA study. And why was this? Well, it turns out that for the FDA study, Alcon, before a patient was allowed into that FDA study, had 3 separate cornea specialists look at the topography and make sure every cornea's topography was absolutely perfect, that there were no abnormalities there. And when you take a perfect cornea, what you find is that the patient's manifest astigmatism is going to be very similar to what is measured on the anterior cornea. So after the FDA study, what Alcon decided to do was to say, to make sure that we're only treating patients who have perfect corneas with Contura, patients should have less than 5 degrees of difference between the manifest astigmatism and the measured anterior corneal astigmatism. And if there was less astigmatism present, these two could differ by 10 degrees or less. And the power between the patient's manifest cylinder and the measured anterior corneal power astigmatism could only differ by 0.75 diopters or less. But it turns out that in most clinics in the United States, only about 10 to 20% of patients will meet these tight criteria. And this is why patients, when they were treated with manifest refraction, were not delivering results that were nearly as good as in the FDA study. So around November of 2016, John Canelopoulos said he had a new idea. And he said, we really have been doing this all wrong. We should really treat off of what's known as TMR, topography modified refraction. And in TMR, what you're doing is you're taking the full measured anterior corneal astigmatism that comes from the vario, comes from Contura, and we're treating the full magnitude and axis of that measured astigmatism. We're not going to pay any attention to the manifest astigmatism. The problem with TMR is it's really a gut check for that surgeon. There's a lot of cases where the manifest astigmatism and the measured differ significantly. So there'd be cases like the one on the top here where the patient in the clinic at the phoropter is asking for minus 0.5 diopters of astigmatic correction. But we're measuring on the anterior cornea 1.79 diopters of astigmatism. And that's a delta difference between the two of 1.29 diopters. And as a surgeon, it's frightening to say, I'm going to put 1.79 diopters of astigmatic treatment on this cornea, even though the patient was only asking for 0.5. Then there's cases like that on the bottom, where the manifest and the measured, they differ by about 0.7 diopters in magnitude, but look at the massive difference in the angle. The manifest, the phoropter, the patient was asking for correction at axis of 70, but we're measuring astigmatism 70 degrees away at 180 degrees. And it was cases like these that made it very difficult for surgeons to jump in and start TMR. But I trusted John. John's a brilliant surgeon. I said, I'm just going to do this. I'm going to bite the bullet. And John was right. When you treat with TMR, we both got better results than when we had been treating Contura based off the patient's manifest refraction. And you can see this at the 20/20 level. Again, my data in orange, John Canelopoulos' data in yellow, comparing to the FDA trial data in green. This is 1 month postoperative uncorrected visual acuities. And you can see we're getting very close to matching what was done in the FDA trial at 2020. The problem is we continue to fall off at the 2015 level. So we still were only getting half as many patients to that 2015 level as we're seeing in the FDA study. So really more work had to be done. And I decided that what was needed is simply to stop guessing. We had Alcon guess at the beginning that Contura topographic guided LASIK, that we should treat off the manifest refraction. And it was a good guess because that's the way we had always done LASIK. It's what we do for wavefront optimized. But at the end of the day, it was a guess. And then the pendulum swung completely the other way and we said, you know what, we should treat off the full measured anterior corneal astigmatism, TMR. But that was a guess as well. And I said, we're refractive surgeons, we're putting permanent corrections on these patients' corneas. It's time to stop guessing. We need an analytical, mathematical approach to determine what the proper treatment should be. And we needed to be able to predict the effects of treating topographic abnormalities, treating the topography, and how this would affect the true anterior corneal cylinder. Then we also found that there were patients who had significant contributions from their posterior cornea. We know this from doing toric IOLs. We're now becoming more and more vested in looking at the contribution of the posterior cornea in addition to the anterior corneal astigmatism as we choose toric IOLs. So really, we should be doing the same thing here for topographic guided LASIK. And in some patients, there's actually some lenticular astigmatism, and so we have to account for this. And then finally, before I was going to put down a Contura treatment on a patient's eye, I wanted a logical explanation for why the manifest and the measured differ. So this is what I set out to do. And I said, we're dealing with topography. So how does the real world deal with topography? In the real world, there's mountain ranges, there's all sorts of very complex three-dimensional topographical features. And oftentimes these three-dimensional topographic features are represented by two-dimensional maps. And it just happens that in the last decade, GIS software or geographic imaging software has been designed that pulls all sorts of technical information about complex three-dimensional structures from two-dimensional maps. And I said to myself, this is exactly what Alcon gives us. They give us a two-dimensional map of the topographic treatment for a cornea, and that two-dimensional map really represents a very complex three-dimensional cornea. So we could use GIS software to pull some very important and useful information out of that two-dimensional topography treatment map. Then I sort of took a step back and I said, really, what's happening when I put the phoropter in front of the patient? What does that manifest refraction? What exactly is it counterbalancing? What is it neutralizing? Well, if you think about it, as light first strikes the cornea, if there's any A or anterior corneal astigmatism, that's going to begin to bend the light. Here on the topographic treatment map, we have a raised curved purple area, and this topographic abnormality is also going to bend the light. And so there's a T or topographic contribution to this. Then as the light leaves the back of the cornea, any posterior corneal astigmatism will play a role, and it too will begin to bend the light. And then finally, L, lenticular. As the light enters the lens, if that particular patient's lens has lenticular astigmatism, it too is going to bend the light. Now, all of these together are what build and create the manifest refraction. We know the manifest refraction. We can measure the anterior corneal astigmatism. We can measure the posterior corneal astigmatism. My software allowed us to determine the topographic contribution to the astigmatism. And then finally, if you have 4 of the 5 variables, if you have the manifest, the anterior, the topographical, and the posterior corneal astigmatism, you can solve for the missing variable of lenticular. And when you have all 5 variables in hand, now you have all the information you need to plan an absolute perfect treatment. Now, if you think about it, these topographic maps, these purple areas are raised curved surfaces on the cornea. And really what that is, it's a lens. It's a curved surface that has a refractive index of cornea on one side and a refractive error on the other. And so these curved areas are actually amenable to optical physics, equations that we've known for many, many years in terms of lenticular effects on light. And so we can apply the mathematics and physics to these areas on the cornea. And that's what we began to do with the software. Now, I want to introduce a term called talus. So as I began developing the software and talking to many surgeons from across the world, I got tired of seeing raised topographic irregularities, and I needed a better term. I thought that since we're borrowing software from geology, let's borrow some vernacular, some terms from geology. And in geology, if you've got a large slope, a hill or a mountain, and superimposed on that curved slope, there's a secondary slope, smaller slope of similar debris. This secondary slope is called a talus. And I thought this is exactly what we're dealing with here on these topographical maps. We've got these raised curved surfaces that form a secondary curvature superimposed on the larger anterior corneal curvature. So I'll use this term talus as we go forward, and this is really where that idea came from. And sometimes these taluses have a huge optical effect. So this is an outlier patient of mine. And in the clinic, this patient was asking for minus 1.25 diopters of astigmatic correction at excess of 90. But the Vario Contura complex was telling me that it was measuring 1.5 diopters of astigmatism at 170. To flip the axis from 1.25 at 90 and then create roughly 90 degrees away 1.5 diopters in the opposite direction, that requires a 2.75 diopter shift. And that's huge. There better be something here that can explain it. And there is. So this white bar represents the patient's anterior negative corneal cylinder. So there better be something 90 degrees away. And sure enough, there are. There's two taluses here that are 90 degrees away from the anterior corneal astigmatism. And it just so happens these two taluses are very large. They're 47 microns high in this case. If you think of Munerlin's law, for every 15.9, 16 microns of tissue removed, we achieve 1 diopter of refractive effect. So something that's 47 microns high is going to have a large refractive effect, and sure enough, in this instance, it does. So it's cases like these that told me how important it was to determine what were the optical effects of these areas of talus, since we're going to remove them when we perform contura topographic guided procedures. So the software will find these areas of talus. It will determine their refractive effect, give that effect a magnitude and a direction. And once you have a magnitude and a direction, now you have something known as a vector. And vector mathematics are especially well suited for analyzing astigmatism because astigmatism is a vector. It has a magnitude and it has a direction. So once the software has determined these taluses and given them vectors, it looks at the other vectors involved. There's a vector for the anterior corneal astigmatism. There's a vector for the posterior corneal astigmatism. There's a vector for the calculated lenticular astigmatism. And it does vector mathematics to put all this together for you to give the correct answer. Now, how does this play out in your clinic? Well, really, your process is not going to change very much. We all get Vario scans on patients that are going to have contura. And after the technician has found the Vario scans, they've analyzed them, they bring them to the Alcon planning laptop. At the Alcon Contura planning laptop, you will zero out the sphere and cylinder so that you get the purely topographical treatment map. We have a way to save these images and then bring those images into the Phorcides software. Now, in addition, we all, as LASIK and refractive surgeons, need to look at the posterior cornea. We need to rule out things like keratoconus. So most of us have a Scheimpflug device in our offices that can do this, either a Pentacam or a Galilei G4. And we can pull these scans, pull this data directly into the Phorcides software. Once you've obtained the topographic treatment maps, again, the Vario scans, we're going to bring them into the Alcon Contura planning laptop. And you'll begin to remove these scans. When I first began giving these talks about a year ago, I had a lot of feedback from surgeons. They said, can you tell us what's your process? How do you eliminate Vario scans? And to be honest with you, I have a technician do this process for me at this point. So the process of eliminating Vario scans should not be as complicated as Alcon made it out to be in the early days. And you can teach a good optometrist or a well-trusted technician to be able to do this process for you. So the first thing that's done is if there's any scans that vary dramatically in color, I tell that technician just to remove those. And once we've removed those that are really out there in terms of color, and we're just left with Vario scans that are similar in color profiles, then I look at a factor known as the MAD. And the MAD really tells us how much these scans deviate from the mean. If you were to average all these scans together, how much do the scans on whole deviate from one another? And what I have found over time is that you want this MAD to be 0.06 or less. So here we've got 4 scans. They're fairly similar in color profile. The MAD is above 0.09. So what would the technician do here? Well, I tell them to play a game of whack-a-mole. What I want them to do is to knock out scans one at a time and see what effect it has on the MAD. So here we knock out the first scan. And as we knock out the first scan, this MAD actually went up from 0.09 to 0.12. So we know we don't want to lose that scan. We knock out the second scan. This also made the MAD go up. We want to keep that scan. We knock out the third scan. The MAD has dropped to 0.06. And at this point, I tell the technician, you're done. Once you've gotten the MAD to 0.06, do not spend any more time on this. We want you to move forward, be efficient. As you've gotten now to the next screen, where you're on the planning screen for the Contura planning software, we're going to zero out our sphere, zero out our cylinder. And when we do that, we get the purely topographic treatment that's going to be applied to this cornea. We also have listed here the maximum tissue ablation at the very tallest peak of each talus. In this case, it's 7.54 microns. And we have a comparison to the amount of tissue that's being ablated topographically at the center of the cornea, here 4.27 microns. And we want all this information to be brought into Phorcides. So at this point, we put a USB stick into the Alcon planning laptop, and you hit the keys Control P. And when you hit Control P, the Contura laptop allows you to save an image of this screen as a JPEG file. And you want to name that file after the patient's name and list which eye, OS or OD. Save it, and then you go through this process again for every eye and every patient that you're going to be performing Contura LASIK on for that next LASIK surgery day. Now, when you download the Phorcides software, a couple things will happen on your desktop. The first is you'll have an icon for the Phorcides software itself. But Phorcides will also create 4 folders for you. One for results, and we'll talk about that a little later. One if you have a Galilei G4, and this is where your technician will drag and drop the files from the G4. One for Pentacam, and again, it's a drag and drop process. We will provide you with a PDF document that walks your technician step by step through this easy process of how to do that. Finally, patient topo exams. And this is where the scans that we just created, where we've zeroed out the sphere and cylinder, we've saved them onto the USB stick. You plug the USB into the computer running Phorcides, and you drag and drop those JPEG files into this folder, patient topo exams. And what I've told my staff is I want all this information to be in these folders ready for me on the day I'm going to be planning my surgery. So once all this data is put together by your technicians, by your staff, you are ready to sit down and immediately begin calculating treatments. We want to make the surgeons as efficient as possible. So this just sort of highlights that we want to pull scans from either the G4 or Pentacam into these folders. We're going to go through some live cases in just a little bit, but before we do that, a little bit of an explanation on why do we need this secondary device. I get a lot of questions, Mark, why do I need a Pentacam or Galilei G4? And there's a couple different reasons for it. The first reason is we need to know about that posterior cornea. So here, as we go through live cases, you'll see this, but this is the topographer posterior corneal negative cylinder. And we need to know what's going on in that posterior cornea. We pull this information from a Scheimpflug device, either the Pentacam or G4. But we also want to know as much information about the anterior corneal astigmatism as possible. The anterior cornea plays a huge role in how light is being sent towards the back of the eye. So we really have to make sure that measurement is accurate. And in looking at about 3,000 cases in building Phorcides, I found something very interesting. And that is if there is a talus that has a short radius to the center, it tends to throw off placido disc topographers like the Vario. So in this case, the Vario thinks there's 3.43 diopters of astigmatism. But the Pentacam, the Scheimpflug, says no, there's 1.3 diopters here. And actually, the Scheimpflug is right. The opposite occurs for taluses that have a long radius, where the talus is quite far from the corneal center. In this scenario, Scheimpflug devices are thrown off, and they will overestimate the amount of astigmatism. So in this case, the Pentacam says there's 4.8 diopters of astigmatism. The Vario says there's 3.15, and in this instance, it's the Vario, the placido disc, that's more accurate. Now, you really don't have to know this. The software does all this for you. Not only does it identify the taluses, but it identifies the radius to the center, and it will automatically find the more accurate anterior corneal astigmatism and use that value. So this is another reason why we need those files from those devices. We're going to talk about some advanced ways that you can analyze the topography. Before we do that, we have to establish a standard. And so what does a standard talus look like? What's its size and shape? So you can generate this standard anytime that you're in front of the wavelight laser. All you need to do is plug in a plus cylinder treatment. So if you plugged in sphere plus, let's say +3 at a certain axis, you're going to see just the purely plus cylinder ablation profile. And see this purple. The shape of this purple, its size, is our standard talus. And so on the left is a patient's actual topographic map. And this particular talus is what I would say standard or average in size. This is what we're after in terms of our standard. So why do we even have to think about this? Because sometimes these taluses are quite irregular. They're very strangely shaped. And so the software here is going to say there's two taluses. And technically the software is right. But really, this very long C-shaped talus needs to be broken up to give it its full refractive due, to account for its full effects. We need to break this into 3 separate standard pieces. And so we're going to show software later how we can do this. You can actually circle standard size pieces and break up the taluses until you're left with standard size taluses. So we'll talk about this in a little bit. Now, it's important to know that for me, the hardest part was always determining what cylinder should I treat with Contura. What's the magnitude? What's the direction? And Phorcides will do that for you. But the sphere is also really critical to get right. And if you look at this particular ablation profile, the purple and the red together make up a circle of ablation that's going to take place in the mid-periphery. And it's going to be removing somewhere between 11.5 and say 8.2 microns in this mid-periphery. But it's only going to be ablating 6.5 microns in the center. And when you ablate more tissue in a torus or donut or mid-peripheral circular shape, this is actually mimicking a hyperopic spherical treatment in wavefront optimized LASIK. So if we're going to treat this topography, we need to account for the effect that this is going to have on the sphere when we correct this topography. In the old days, Alcon had us do this by hand. So I came up with this method early on, TCN, and I used to use this TCN method that I came up with by hand. And so first I'd account for the topography change. And what you would do is you'd zero out the sphere and cylinder, you'd slowly add in very small amounts of sphere, and as you added more spherical correction, you would ablate more tissue in the center. And so the difference between max and center would decrease. And you'd keep adding more minus, in this case, minus 0.15 sphere, until the difference between the max and the center was 3 microns. And then I would stop. Now, other surgeons, rather than do and balance by ablation depth, they would balance out Zernike coefficients, but it was the same concept. You'd keep adding minus sphere until the Zernikes would balance or the ablation would balance. Phorcides does all this for you. So Phorcides knows it will measure how much tissue is being ablated in the mid-periphery versus the center, and it will adjust a topographic treatment to your sphere. C for cylinder. Oftentimes we are treating a different magnitude of cylinder than the patient had in their foreopter manifest refraction. So in this particular case, for this eye, we're treating minus 0.8, but the patient asked for minus 0.5 at the foreopter. That's a difference of minus 0.3. So to maintain spherical equivalency, we have to take that difference, divide it by 2, change the sign, and add it back to the sphere. And this is what I did here. In this case, that's a plus 0.15. And then finally, we all know from doing LASIK that the higher amounts of myopia that you treat, you have to apply nomograms so that you don't overcorrect that cornea. We have a proprietary nomogram that's built in. So when Phorcides gives you the answer and tells you the sphere, cylinder, and axis to treat, this number, this sphere, has already been calculated with a nomogram. Surgeons will sometimes make the mistake. They'll say, well, I'm going to take my manifest, run it through my usual nomogram, and then take that and run it through Phorcides. Do not do that. Now you're running the nomogram, 2 nomograms on the same sphere. You're going to double dip. Or some people will say, well, I'm going to take what Phorcides recommended and run that through a nomogram. Again, wrong answer. You don't want to apply 2 nomograms to a single eye. Phorcides does all this for you. It gives you the correct sphere. We're going to talk more about the treatment recommendation image that we're going to see, but this is what Phorcides generates. It, again, gives you the recommended sphere, cylinder, and axis, and these are correct. It tells you which eye that we're working with, and then it gives you a vector diagram because we want to explain why. Why is this patient's optics the way that they are? Why is the manifest here different from what's being measured? We're going to talk about that in a second. As you get this treatment, you can hit save, and it will save the results into the Phorcides results folder. Now I mentioned one of the reasons I built Phorcides is I wanted a logical explanation for what was going on in the eye, why the manifest and measured differed before I put that treatment on a patient's eye. And this is where the vector diagram comes up with. So in this case, the patient asked for minus 0.5 at 170, but we're measuring more astigmatism in this eye. So the green corneal astigmatism, this vector area right here, represents the total corneal astigmatism, the contribution of both the anterior and posterior corneal astigmatism. The golden arrow is the patient's manifest refraction. And so we can see its direction and magnitude. So what's going on in this particular case? In this case, there's a vector here from the talus astigmatism. And because this vector is 90 degrees away from the corneal vector, it's going to reduce the amount of astigmatism that's being contributed by the anterior cornea. It's going to negate some of its effects. Now there's also this red vector here, and in this particular case, Phorcides calculated there's some internal astigmatism. And again, remember, cylinders have their effect 90 degrees away, and if 2 cylinders are 90 degrees apart from each other and they have the same magnitude, they counterbalance each other. So we've got one vector here from the talus, we've got a vector from the cornea, we have a vector for internal. Phorcides will take all this into account and give you the treatment that's needed. It also is explaining why was this patient asking for more astigmatism than was present simply by some of these vectors. It kind of gives you the answer of what's going on optically in that eye. Now, there's 2 different forms of software that's used by Alcon for their planning laptop. There is the much older SP3, which has a gray background, and there's the newer SP4. And most people have now been converted to SP4. There may be a few holdouts using SP3. It's important to know that Phorcides will work with both, but you'll have to tell Phorcides which version that you're using. When we're done, just want you to know that there is a website, phorcides.com. A lot of good material on here. There's videos that teach various aspects of training for using Phorcides for Contura, for wavefront optimize, how to use the cloud. There's some case studies on there as well, so I encourage you to check that out. Now, why go through all this? Why go through all this effort of learning how to use Contura, learning how to use Phorcides? Wavefront optimize was really good. It's easy to do, so why make that switch? And before I rolled Phorcides out to other surgeons, I had to prove to myself that it was safe and that it was better than wavefront optimized. So I did an internal study in my own clinic, and I took 60 patients. This was a contralateral eye study. I treated one eye with Phorcides plan contura, and the patient's contralateral eye received wavefront optimized treatment. And then I waited a month and looked at the uncorrected visual acuity. I wanted to see which eye had the best uncorrected acuity between the two treatments. And it turned out that in 55% of the eyes, 55% of the patients, the Phorcides plan contura eye had better uncorrected vision. In 35% of the patients, the Phorcides plan contura was equal to the wavefront optimized eye. And I'm okay with that. Wavefront optimized is a beautiful procedure. It gives great results. I get lots of patients at 2015. A lot of this 35%, both eyes were 2015, and that's fine with me. Only about 10% of the patients had the wavefront optimized eye perform better than the Phorcides plan contura. And even in this 10%, the Phorcides plan contura was not far behind. In terms of safety, we looked at the same safety parameters that Alcon used for the FDA trial for contura. We wanted to make sure that the uncorrected visual acuity was within one line of a patient's pre-op best corrected acuity. And sure enough, eyes planned with Phorcides, 99% meet this standard. In fact, a surprising 38.5%, almost 40%, had uncorrected visual acuity one line or better than their best corrected visual acuity. This is data from Carl Stonecipher. He's been using Phorcides from the beginning. He wanted to look at the results for wavefront optimized versus TMR contura versus TCAT contura. TCAT contura uses the manifest refraction matching the parameters of the FDA study versus contura planned with Phorcides. And what he looked at is, what are the patients really seeing day one? Both eyes open, uncorrected visual acuity, walking into your clinic post-op day one. Phorcides beat every other modality. 100% 2020, 84% 2015 uncorrected binocular vision, 16% 2010. So even first day out, you're getting that wow factor and you're getting excellent results, better results with Phorcides than the other modalities. This is data that is preliminary. It's going to be published very soon. This is 4 United States LASIK centers, 4 surgeons, all the same surgeon at these centers. And in this particular study, we planned eyes with Phorcides and we planned some eyes with contura off of manifest refraction. And I'll show you that data in a little bit. But the Phorcides planned contura eyes, 96% at 3 months were seeing 2020. 63% were seeing 2015. And this beats the FDA data. So it beats the FDA data at the 2020 and 2015 level. You say, well, okay, so what? The reason this is so impressive is, remember, the FDA study cherry-picked the patients. The patients had perfect corneas. Corneas that are so good that only 10% of the patients who walk into a clinic have these very tight parameters where manifest and measured are so close to one another. But in the study that we did, every patient who walked in the door was entered into that Phorcides planned contura. So we took all comers and beat the FDA. This is data from Carl Stonecipher, looking at about 2,000 eyes, looking at the enhancement rates. The enhancement rates, fortunately, are low. Wavefront optimized is a great treatment. Wavelight is a beautiful laser, but Phorcides beat them all. 0 enhancements were needed in his study. And in my data, when I looked at all the patients that I treated last year, treated with Phorcides, I had about 1,400 eyes. Out of the 1,400 eyes, I only had 1 that needed an enhancement. And for me, that was the best I'd ever seen. Once you get the Phorcides software and you begin to load it, it's going to ask you to register. And this key is going to be asked of you. When you do see this, just take a picture of this, take a screenshot, email it to either your Alcon representative or to myself. And using the ID number, we'll be able to generate you a key code so you can begin using Phorcides. And now we're going to kind of switch gears. We're actually going to calculate some cases. I'll show you how the software works. So let's switch over. And as we said before, when you first download Phorcides, you get the icon that represents the software and 4 folders are created. We've got all the information already put away in the topo exam folder, the Pentacam G4. So we're going to double click the icon. As we do this, it's going to ask me to log into the Phorcides cloud. Phorcides cloud is new. It's a very powerful tool. It helps you really carefully track your preoperative information for patients, what the planning was for Phorcides, what actual treatment you did that day for LASIK, and what the postoperative results are. It's also going to have full analytics to help analyze all of your LASIK results. To take advantage of all this, you want to make sure that you register for the cloud, and there's videos on the Phorcides.com website that tell you how to register. I've already registered, so I'm going to enter in my email. Now, you can ask it to remember you so you do not have to do this each time, and you can simply log in. If you don't want to take advantage of the Phorcides cloud, you don't have to. You can simply hit the skip button and immediately begin using the calculator. But I'm going to hit that log in. So Contura, we're going to plan a Contura treatment. We also have a new wavefront optimized calculator that we'll talk about in a bit. But let's open the Contura. So we now have the Phorcides calculator here. And the first thing you want to do is open up the patient's image that you want to plan a treatment for. So we'll open up this patient's left eye. Phorcides will pull in the image that came from the Contura planning laptop, and then it magnifies the important data here. The manifest refraction, what was measured by Contura and Varia. We can confirm first and foremost, was the sphere and the cylinder set to 0? That's the first step. You really want to make sure that they didn't make a mistake and leave in like a -4 here or something. So you want to make sure this is zeroed out. You can see that it's pulled in the patient's ID, their date of birth, their name. We've identified that this is the left eye, so you cannot plan the treatment for the wrong eye. This is a black background. I'm using SP4, so you have to see the SP4 software has been chosen. If I was using an SP3 image, I would choose SP3. So this is how you toggle back and forth. Target refraction, where do you want this patient's eye to end up with when they're fully healed? And in this instance, the default is 0, plano. But let's say you've got a patient who's very young, who's 18, and you want them to end up just a little bit hyperopic. This is where you type that in. If I want this patient's eye to end up postoperatively at plus 0.25, here's where I can tell Phorcides to do that. If the patient is, let's say, 49, and you want to put in some monovision, maybe a 1.6 diopter outcome, this is where you would target that. So it gives you that ability. It's really pretty nice. The first thing you want to do is use Phorcides. You want to click on this first box. Boxes in light yellow, Phorcides is telling you that it has tried to read the information that came from the Alcon planning laptop, but it needs your verification. Well, why do we have to do this? Alcon currently provides a very low resolution image from their Alcon planning laptop. And because this image is so low resolution, when we built Phorcides, we built software called OCR, Optical Character Recognition. Phorcides is trying to save you time. It's trying to read these numbers for you and fill in the data for you. But because Alcon has given us such a low resolution image, we need to make sure that you verify these numbers. So as you first click this box, you'll see this golden box appear. The golden box is leading you, telling you what should be in the data box, the data field. And you simply, once you've verified that first box, you hit tab and both jump over. And so we're just tabbing across, confirming that that data is correct. As we get to white boxes are 100% accurate. This data has been pulled directly from the Pentacam or Galilei G4. There are no errors, so I tab very quickly through that. The max in the center, these are the ablation of the highest, tallest peak on the talus versus the center. 10.34, 10.34, 5.63 for the center ablation. We've confirmed these numbers. We hit analyze. Phorcides will ask you if you've personally confirmed this, and we have, so we hit yes. Phorcides has identified the two most significant taluses. I'm satisfied with its analysis, so now I hit calculate treatment, and we're done. We've been given the correct sphere, the correct cylinder, and the correct axis. We can confirm that we're targeting plano. We can confirm that we're working with the left eye. And then a quick visual representation of what's going on here. Why is the patient asking for no astigmatic correction in their manifest, but there's 0.41 diopters of astigmatism on the cornea? Well, here's our answer. Here's the corneal astigmatism vector, and along the 0, 180 degree meridian. There's also internal astigmatism, that's at the same meridian. And so these two vectors, the red internal and the green total cornea, will actually combine, they're in the same axis. So if the patient's not asking for any astigmatism at the phoropter, there better be something 90 degrees away, equal in magnitude. And there is. In this particular case, these taluses are aligning just right with the right height, that they're creating a vector that is equal to these two vectors added together. And it's 90 degrees away, so it's negating their effect. So very quickly, visually, I confirm, I understand what's going on optically with this patient. It makes logical sense to me, and I hit save. And as you save, a couple things are going to happen. There's a results folder, Phorcides results. So your cases that you plan are always saved on this desktop folder. And for every date, to date happens to be, today is November the 20th, it creates a folder for all the cases that I planned today. And so I can go by date. And so every single patient that I plan for today, we had a busy day of LASIK surgery, all these patients are in this folder. The other way you can look for them is within that same folder, every patient who's ever been treated by Phorcides, everyone you've ever saved is here. So all your patients are there in one database. You can easily access them at any time. If you have registered for the cloud, and if you signed in before you use the calculator, this information has also been brought up to the Phorcides cloud. So let's take a look at that. We can, well, easier ways maybe to access the cloud here. You can click this button, and we're going to open the dashboard. Every surgeon, when you register for Phorcides, will have their own dashboard, and it lists who you are, what clinics you work for, and you can list multiple clinics if you do LASIK at multiple clinics. Patients and events. Every time a patient is touched by you and your clinic, we call that an event. A pre-op exam is an event. Phorcides planning is an event. The LASIK surgery itself is an event. Day 1, 2-month, 3-month, 6-month post-ops are events. So we built this really nice feature to kind of be able to access that data very quickly. It's called Events Timeline. So we click that. And here I can search patient's name. And you can see we did this Phorcides contour planning right here. And we planned it on this date, and it's saved it here. As soon as you plan with Phorcides Contura, Phorcides in the cloud will automatically create a pre-op exam for you. So you can click that. So all the data, the manifest refraction that came from that planning that we just did through Alcon's Contura, that gets pulled up into the cloud. And this is really helpful for your technicians. So rather than the technician having to go in, type in the patient's name, their date of birth, their ID number, go back, type in the manifest refraction, create this pre-op exam, it's all been done for them. And all they have to simply do is say, what was the patient's uncorrected vision before surgery, and what was their best corrected vision before surgery? And they save that event, and they're done. Now, we can access all the patient events from here, or you can X out, and you can once again go to the timeline. And we can look, actually this patient actually had gone through surgery, so we can see the surgical planning. If the patient, if you want to create a new event, you simply click new event, event type. Let's say it's a post-op event, the date, which eye that we're dealing with, who is the surgeon. of the surgeons that are present at the clinic. You can choose the surgeon who did the surgery and also what technician is putting this data in. So very easy to keep track of everything. We'll kind of go into the cloud a little bit more, but we're going to head back and do some more planning here, show you how Phorcides planning works for Contura. So we're going to open up the next image. And again, we've brought all the information in, ID, date of birth, name, identified this as the left eye, target refraction. We're going to check these boxes. Now, sure enough, 1.75, and it is misread as 0.75. So we're going to type in a 1. This is the step with Phorcides that you want to slow down. You really just want to take a few seconds. It doesn't take long, and you simply make sure the data's been entered correctly. And we hit analyze. We've confirmed the data is correct. Now, we talked about standard size taluses. Here's 2 taluses, but this upper one really has 2 lobes to it. And each lobe is a standard size. So how do we account for that? What you can do is use this powerful tool called the talus finder. And you can take this arrow. What you never want to do is you don't want to take this arrow and move it to the left, because you decrease the sensitivity so much you start picking up a lot of garbage. But if we take it and move it to the right, now we've been able to decrease the sensitivity. We've been able to split this one talus into the 2 lobes, and this is a better way to truly account for the refractive effects for the topography in the eye. It only takes a second or 2. So let's just kind of go back. We're going to hit analyze. I'll show you how long this takes me. I usually will grab this and I hit calculate treatment. Literally takes less than 10 seconds. Have a recommended treatment, cylinder, and axis again, and we would hit save. Now let's plan another treatment. We'll open up. So we're opening this patient up, and immediately a couple things jump out. We don't have the patient's ID number, and I'm missing my Pentacam data. So what's going on? Again, we get such a low resolution image from Alcon that the software is doing its best to read numbers and letters, but sometimes it mixes things up. So if you're missing this Pentacam data, the first thing you want to do is check the spelling of the name. And sure enough, this is not Rose Marv, it's Rosemary. And these T's are not correct. Those are just different characters. So when we spell the patient's name right, immediately Phorcides goes back, finds the right ID, and finds the right data for you. So in the near future, we're going to have an export tool that will export all this data with 100% accuracy. So you're not going to have to deal with this very long. But until we have that export tool, I do encourage you just to take a step, make sure everything on this data page is correct. So we'll also correct here. And we hit analyze. And we've got this collection here. Now it's identified 2 taluses, but I think this is really 3. So again, I'm going to move this just a little bit. And now we have all 3 taluses identified. 1, 2, 3. Just take a second and make sure it's analyzing those the way that you want. We hit calculate treatment. And we would again save. So let's open another final one here. Let's plan the right eye and make sure the data is entered correctly. Hit analyze, and notice what came up, a warning. Unusually large difference between Contura's and the topographer's axis has been detected. What's going on here? Well, Contura Vario says that the astigmatism is at 114 degrees, but the Pentacam or Galilei G4 is saying, nope, the astigmatism is at 172 degrees. If there's a big difference between the magnitude of the cylinder or the axis of the cylinder, Phorcides is going to warn you. Phorcides always has your back. It always has the surgeon's best interest at mind. So if there's a big difference, it's going to warn you. It's just saying, Just double check your work. And we did. We've double checked. These numbers are correct. And if they're correct, you proceed. If you made an error, go back and fix it. So it's a safety feature that's built in. Now, in this particular case, again, the automatic features, you can simply have the software calculate all the treatments for you on its own. And it's fast and efficient. It's also very, very accurate. So don't think that you have to use these more advanced tools. If you simply allow the software each time to find the talus and hit calculate treatment, you will get excellent results. And in fact, Carl Stonecipher says he gets better results using just the automated, letting Phorcides do it on its own than he does by self-selecting. I tend to be very hands-on. I want to be able to manipulate things, so I built in some tools. So in this instance, I think there's a raised topographical feature here and over here. So I want to account for them. So if you take your mouse, you can draw a standard size talus. When you do that, Phorcides is going to say, well, how high is this talus? What's its height? So you've got this color map here, and this is kind of a darker red. And that matches the darker red here, and that's 70%. So we're going to give this a 70% height and hit OK. There's another talus over here, and I want to circle a standard size. And that's where we talked about standards before. Again, very similar color, so again, another 70%, and we hit OK. We hit calculate treatment. And so you can use these tools, you can play with them on your own, you can get adept at them. You can decide to use them or decide not to. But I wanted to build a lot of different features and a lot of flexibility. But let's say you looked at the sign and said, you know, I really don't want to use Contura here. I think I'm going to just do a wavefront optimized treatment. Well, what you can do is there's a button here called Transfer to Wavefront Optimized. And you can click this. And it asks you if you want to load all this Contura data over, and we do. And so Phorcides has automatically loaded all the data for you into the Wavefront Optimized calculator. No typing. ID, date of birth, name, which eye. You can choose whether you're doing LASIK or PRK. If you're doing LASIK, it's going to remember what laser you use. You don't have to type this in every time because we typically don't switch lasers. Flap creation. So it's going to remember what you use for your flap. If you're using the FS200, if you happen to have an interlace, if you're using a microkeratome, it will remember your selection. You can always change it, but most of us are not switching the methodology that we use to create a flap. So we're going to keep that standard. Again, our target refraction, you can choose what that refraction is going to be. You've got the refraction, the manifest pulled in from this data. It has pulled the flat anterior corneal astigmatism and the steep anterior corneal astigmatism from the pentacam or G4, both the magnitude and the axis. It has found the central pachymetry for you. We typically will make the same thickness flaps over and over. So it remembers your last selection, but you can always change this and it will remember that. It has calculated the overall nomogram, a global nomogram. Once you've saved enough of your cases into the cloud, it will create a surgeon-specific nomogram. So another reason for you to use that cloud. But most of us know that with Wavefront Optimized, you must treat in quarter diopter increments. And this is 1.55. So we're going to round this, and you hit the round button, and it can round it for you. Now, some surgeons don't want it rounded. They want to see, okay, what are these 2 decimal points? They'll round it themselves. Fine, you can display it this way. Others say, do it for me. Round to the closest quarter diopter. No problem, hit the round button. We have the estimated ablation depth for this treatment. We also have the residual stromal bed indicated here. So these are nice to have, so you make sure that you're not treating too much tissue in the eye with this particular treatment. And again, just like before, you save the results, and it saves it in the same spot. This is the patient's right eye. Let's say we decided, okay, we want to also calculate the patient's left eye for LASIK with Wavefront Optimized. You have to unlock this data. And so you unlock it by clicking this pencil icon. We're going to make an edit. And we're going to select the left eye. But we don't have to type all this information in again. The ID follows, so does the date of birth. It's remembered all the other features that we selected before. Now we just have to type in the sphere. Let's say minus 2.5, minus 1 at axis 90. Let's say your clinic works in plus cylinder, no problem. Hit plus cylinder. Everything's remembered in plus cylinder, including your treatment. Work in minus, no problem. Both the manifest and the treatment are in minus. Don't want to round it, click the button. And again, we can save the results and it will save it for us both on the computer and up in the cloud. So really that's what's behind Phorcides at this point. It's getting more powerful all the time. There's a lot of features to it. I'm very excited that you're going to start off with it. If you've got any questions, you can always reach out to me. My email is simply my name, M for Mark, Lobanoff @gmail.com. If you contact your Alcon representative, they can also get you in touch with me. I'm happy to help with it if you've got a complex case or you're just not sure about your first couple cases that you're planning Phorcides Contura. By all means, let me help you out. So hope this was helpful, instrumental. One final thing before we conclude today, and that is, let's pull this back up. What is the future going to hold? So, excuse me, we are going to have a monitor in every single LASIK room. This monitor is going to sit next to your current monitor on the wavelight laser. Phorcides is going to have the advised treatment that you planned. It's also going to look and see exactly what treatment is in the laser, has been put in by the technician, and is about to be treated on the patient's eye. Phorcides will take that planned treatment and compare it to the actual treatment that's in the laser. If those two are in agreement, you'll get a green light, full go ahead. If they are not in agreement, if your planned treatment does not match what the technician typed in, let's say they made a mistake, -1.5, Phorcides is going to warn you with a bright red circle, full stop, determine where the difference is. So this is coming soon. Also, some other things are, pardon me, this device here measures temperature, humidity, and atmospheric pressure. It measures it continually for really continually every single day. Once a week or once a month, you can take off this cover, attach it to the drive on the computer that runs Phorcides. Phorcides will pull all of this information up into your cloud. This information, we all look at temperature and humidity each day as we sit down and do LASIK. We want to make sure they're within the norms, but nobody really writes that down and then looks at what effect that has on your nomogram. Phorcides is going to do this for you. A clinic that's in Denver, that's at 6,000 feet, has a different atmospheric pressure than one in Louisiana at sea level. And so how does that atmospheric pressure differ? How does it modify changes in your nomogram? We're going to know this. We're going to be able to have that specific for you and your center. In the near future, again, we're going to have an export tool from Alcon that's going to have not only 100% accurate data transfer of names and numbers, but a much higher resolution of this topography map. And using a higher resolution map, we're going to use more advanced mathematics known as differential geometry to become even more accurate in helping you get the perfect treatment for every single eye. And finally, once a surgeon has entered enough of their Contura cases, their post-op results, into the Phorcides cloud, we have experts in artificial intelligence who have built in artificial intelligence to help modify your surgeon-specific nomogram, something no one else in the world has ever done for surgeons. So all this is coming. We're very excited about the future. Thank you again for learning more about Phorcides, and I hope you do well with it.